begin my class, my lecture for this week. Not met me before, so I'm Kelly. So I'll be actually taking care of reaction engineering for the semester July 2021 with you guys. So I'm supposed to have 23 students, but now it's only 16. But it's fine. I have the video. I'll record this class as usual. All my classes will be recorded, and then I will embed it in YouTube, and I will have it in the VLE. So if any of your friends miss the class for any other reasons, just make sure that they view the video later on the VLE. Okay, all right. So before I begin, just a little bit introduction of myself. Again, as I said, I'm Kelly. I've been teaching reaction engineering. So this is 2021 July. I've been teaching this course for every semester since 2013. So this is my 8th year. So this is my 16th semester teaching reaction engineering. Okay, so from there, you know that I've taught this semester, I've taught these courses for a long time, and there's a reason. Okay, why I teach reaction engineering. One of the reason is because actually, again, I've been teaching this course for a very long time, and second, actually my PhD is in the field of reaction engineering. So why do I say this? Why do I say that my field is important? Because I believe that since my field of PhD is in reaction engineering, in fact, my master's and my PhD is in the field of reaction engineering, I should be able to actually help you to really understand the course. Okay, so some of you might wonder, you have taken a lot of courses, right? But throughout the whole 4 years, if you realize there are only 2 courses with 4 credits, is CPP, which you have taken, and second, reaction engineering. So you perhaps wonder what is so special about these 2 courses, especially reaction engineering, that it is a 4 credit semester. Okay, so let me first talk about what is actually reaction engineering. You probably have heard of reaction. Okay, you have taken chemistry, you have taken other courses, you have heard about reaction. So you know that reaction is basically chemistry. So chemistry branch of our studies. Now, but the course is named as reaction engineering. So it's no longer about the chemistry of the reaction, but reaction engineering is about the engineering of a reaction. Meaning to say, if you realize, or if you have not realized, if you Google out information, you realize that most, if not all chemical plant that produces chemicals will have one equipment that we call reactor. Okay, so what is this important about reactor? In fact, reactor is what we always say, the heart of a chemical plant. Okay, so imagine you're human, you have a heart, right? So it's the same. In a chemical plant, they always say reactor is the heart of the plant. Meaning to say that of all the equipments that you may have in a chemical plant, okay, the one that they will emphasize more on the design, on the engineering aspect of it, will be a reactor. So why? Because reactor is where reaction takes place. Okay, so what we're going to do for the next 17 semesters, we are going to actually study, understand, and design reactor. Okay, then perhaps your next question, what is so difficult about designing a reactor, right? Okay, you have learned about reaction. Okay, if you realize reactions are very diverse, it's not only one type of reaction, you have many types of reactions. One. Second, reactions may and will have different mechanism. Two. Three, you know that reactions are influenced by many operating conditions. Okay, pressure, temperature, flow rate, so on and so forth. So the changes of operating condition also influences reaction. Then when your reactions are so diverse, the reactor design will also become very diverse and very complicated. And if you remember, we learned about, you have learned probably about catalyst. So then the inclusion of catalyst in your reactor will also complicate the design of reactor. That's why you will have 17 weeks of learning how specifically to design only one equipment, which is a reactor. But as you go on, you will realize how complicated it is because of the nature of reaction. Okay, so perhaps some or most of you have already asked your seniors about this course, and probably some or most of them will say the course is very tough, which I agree the course is very tough. Okay, so if you ask me, how are you going to go through these courses? First, please come to the classes. So I understand that sometimes you, especially in this pandemic, sometimes you find it, you have issues, sometimes you find it hard to attend to classes, especially on 8:30 a.m. classes. I do understand, okay, for attendance, although it is compulsory for you to attend classes, but if you ask your seniors, I treat my students like adults, meaning if you cannot come, okay, I won't actually scold you or anything, but I would like to just I would just request that you just text me. Later I will have a phone number. I will give you my phone number. You just text me and inform me if you cannot come for the class. I won't even ask you why. I understand humans, we have reasons, sometimes we have different problems. I wouldn't even ask you why, but I would like to just request that you just text me personally before the class if you cannot turn up for the class. Okay, then don't worry. All the video teaching of my classes, including tutorials, I will put it in a VLE, I will embed it in YouTube, and I will put it on VLE. So you can always check the video. Okay, so second, why is it very important for you to attend classes besides the fact that it's compulsory, right? Second is because reaction is a course that I always call it as a building course. What I mean by building course is that in order for you to understand the chapter ni is related to one another, meaning let's say if you miss the lecture in chapter 1, it will be very hard for you to catch up in chapter 2 sebab dia adalah course yang membina, meaning chapter 1 is needed to understand chapter 2, chapter 2 is needed to understand chapter 3, so on and so forth until chapter 8. So if let's say you cannot catch up any time between the chapters, if let's say you miss out, the problem is not only for that week, the problem will then snowball for the next week. So I speak this based on my experience. So usually students kalau dia tertinggal, okay, when sometimes you miss out, then you become a little bit, you become demotivated, that's the danger. Okay, so dia memang course yang susah. Memang saya tak pernah cakap course ni tak susah. It's a very difficult course, but you really need to actually turn up for the course, turn up for the class, turn up for tutorial. I will really help you. You can ask your seniors. I will really help the students in reaction engineering because I understand it's really 4 credit hours. A poor grade in reaction will really bring down your CGPA. So I totally understand that part. So commitment tu yang penting lah. I can really help you to understand this. It's hard, but I can really make you understand. You just need to attend class, attend tutorial. I think should be okay, right? Okay, so baru saya nak start lecture, baru saya nak start notes. Okay, so since it's pandemic, I won't be able to see you face to face, but if ever, someday, if ever we come back to campus, my office is in the admin building. In fact, my office is only 2 office before the staff cafe. So if you go the corridor, ground floor, my office is on the left-hand side. 2 doors before the staff cafeteria is my office. I have my name on it. So if we ever come back physical back to campus, you're always welcome to come to my office. Next, my contact number is there. I thought of not having a WhatsApp group for the course, but the other course requested to have. So I think I will also have a WhatsApp group for this course. Then later I will put the WhatsApp link in VLE. Please add yourself to the WhatsApp group so that if any announcement, any emergency information or what, I can share it on the WhatsApp group. So I will create the group later. Okay, so my phone number is there. All right, my email. So communication, you can choose email, you can choose using WhatsApp, text. Okay, call, I rarely pick up calls. So please do text me first. Okay, so if you have anything that you want to inform me. And the course material for reaction engineering, everything is on VLE. I use heavily VLE. In fact, if you check the VLE right now, I already uploaded everything that you need to know about the course, including the notes, so on and so forth. So the notes I will usually upload before the class, and the video will be uploaded immediately after the class. Okay, so please always check the VLE for all the information regarding this course. Okay. So next one, your course timetable. Okay, so if you have seen your course timetable, there are few things that you need to understand. I will take care of your lecture and tutorial. So we have tutorial 2 section, right? T1 on Monday and T2 on Thursday. Okay, so far we will not have tutorial class yet. Okay, usually we will start tutorial in week 3 or week 4. I need to finish at least until chapter 2. Only I can do tutorial. Okay, so we will not have tutorial for the meantime. We will only have a lecture. Right. Your laboratory is not under me. Your laboratory is under Madam Nurul Akmal. Okay, but I not sure when you will come back for lab. You will probably come back for lab, physical lab, but I'm not too sure when. But once the date is announced, I will inform you accordingly. Then you need to contact Madam Nurul Akmal for the laboratory arrangement. Okay, so lecture today 8:30 and also on Monday 4:30. Okay, so my lecture, unless I inform that it's cancelled, the lecture is on as usual, and I rarely or never, I would say rarely lah, cakap never tak boleh pula. I rarely skip my lecture or my tutorial. I will always have it, and I will always have it on time. So please make sure you come to my classes on time. If you ask your seniors, they know my style. I'm quite flexible, but time is, I'm very particular about time, meaning I'm very punctual, including expecting deadlines on submission of assignment ke apa-apa pun. I'm very particular about timing. So my class, if you realize today, my class start on the dot at 8:30 and my class will end on the dot 9:30. So please make sure you come on time for the classes. Right. So now before I talk about course assessment and make you stress about assessment, let me cool down first. Let me talk about reaction. Okay, so let me try to introduce the course to you first. Okay, so macam tadi mukadimah yang saya cakap tadi, you know that there are various types of chemical reaction in everyday life. You don't even need to go to a chemical plant. Even in your daily life, you can see there are many types of reaction. So you must understand every reaction is very unique. So each reaction has its own characteristics. So these characteristics that makes it complicated when we want to design a reactor. Okay, so for example, all right, sorry, let me come back. Okay, so for example, basic reaction, you will have like nature reaction, photosynthesis, you have baking. If you like to bake, baking is also actually a type of reaction. For example, fermentation, for those from bioprocess students, you probably heard about fermentation. So fermentation is also a type of reaction. You heard about combustion. Combustion is the most basic reaction. So combustion is reaction with oxygen. When you have oxygen, okay, at a sufficiently high temperature, high pressure, you will have what we call as combustion reaction. Okay, so next. If you want to have further information regarding the course, okay, the course learning plan, the course syllabus is all on VLE. I highly advise you to actually check the course syllabus, course plan for you to know more about what you're going to learn in this course. Okay, so let me start by explaining a very basic reaction in order for you to understand reaction engineering. Okay, let's say now, right, you like to bake. Okay, let's say you are good at baking, or you probably have heard of many people who are good in baking. Okay, so what entails a baking process or baking reaction? Okay, so whenever you have a reaction, for example, baking, you always have what we call as starting material, or we call it as raw material, or we will call it as reactant, or sometimes we call it as inlet. So all these means the same thing, the starting material for the reaction to take place. So that's why we call it reactant. Reactant is the materials that is going to react. Okay, so any reaction will have to have the starting material that we call as reactant. So in a baking, probably you know baking will need flour, you will need eggs, you will need oil, so on and so forth. So this is your reactant. So after this, when you heard the word reactant, you must understand reactant. Sometimes I use reactant, sometimes I use raw material, sometimes I use inlet, but it still means the same. The material that exists before the reaction occurs. Okay, now, then reaction takes place. Okay, so reaction takes place, then you will have, after the reaction has taken place, you will have product. Okay, so then how do we know a reaction has taken place? Okay, senang je. Nak tahu whether a reaction has taken place when you have something, the end product is no longer what you put in the beginning. So let's say kalau kamu letak raw material kamu, after the reaction takes place, you see that what you get is no longer what you put in initially. So when that occurs, that's when reaction takes place. And what that you get after the reaction, we call it as product. So for example, katakan you put in A and B, okay? After reaction, you get still A and B, then it means reaction doesn't take place. But let's say if you react A and B, after reaction, you get C, a new product, then a reaction has taken place. So product is what we get after the reaction. So what I explained this is the chemistry part of reaction, which you have already learned. Okay. But what you're going to learn in the next 17 weeks is the equipment or the device where the reaction takes place. So we call this as reactor. So in a baking, usually where do you bake? You will bake in an oven, right? So essentially, an oven is a reactor. Why? Because the baking, the reaction takes place in an oven. Hence, the oven is actually a reactor. So do you know that? Okay. To design an oven, sorry, if you probably you have not known this, but designing oven is also a complex process, you know. Okay, why do I say it's complex? Okay, do you realize that when you are baking, there are few parameters that you need to take care. One, you need to know the temperature of your baking. Okay, you can't be baking it at room temperature. Nothing will happen, reaction will not take place. Usually you will bake at certain temperature, but you realize that you can't simply choose. Let's say you read from the magazine or you read from the internet, they say you bake at high temperature, but they don't specify the temperature. So you try to bake at 140, you might realize your cake is undercooked. Then maybe perhaps you think that I have to go higher temperature, you cook at 300 Celsius, you get a burnt cake. Okay, you realize that the optimal temperature of baking is usually 180. So perhaps you wonder, why is it so specific? That is the specificity of reaction. It must occur at the optimum condition in order for you to get the optimal product. So that's one thing that you have to consider. Even you have a reactor, but the reactor, the oven has to work at certain temperature, only you will get the optimal product that you want. Next, baking time. Okay, you need to know a specific time for you to produce or to obtain a good cake. Okay, short time, too short time or too long time, you will get either an undercooked cake or a burnt cake as well. So there must be a specific time. So that's also two factors that you really need to consider when you're talking about oven. Third, do you realize the what? Saya lupa nama dia. What do they call it lah? Nampak saya tak pernah baking kan. Acuan, what's acuan in English Acuan, sorry, I miss out. I really don't bake. Acuan, do you realize if you have the acuan, okay? Do you know that the acuan will have different shape, right? You might have a spear shape, you might have a circle shape, you might have a triangle shape, so on and so forth. Do you realize the height of the acuan also plays a part? So if you have a very high or very large acuan, let's say the height is very high, it also will take longer time to cook. So you realize that the dimension of the acuan also plays a part in baking the cake. So you realize these are the several factors, but that in fact there are many other factors that you need to consider as well when we're talking about baking a cake. And if you realize, even by adding an additional ingredient or taking out ingredient from the taking out the ingredient from the reaction itself will also influence your cake outcome. So that is how complex reactions and hence the complexity of the reactor design as well. Okay, now we will talk in a more scientific chemical engineering way. Okay, now let me talk about a very common reaction. We call it as Haber-Bosch ammonia reaction. Okay, so first of all, why is it called Haber-Bosch? Haber and Bosch, Sir Haber and Sir Bosch are the two chemists that found a way to produce ammonia, ammonia NH3, and they found that ammonia can be produced by reacting nitrogen gas and hydrogen gas. Okay, so now at one time, okay, this was back then, ammonia is used heavily. I think until now also is used heavily for the production of fertilizer. Okay, so at that time of Sir Bosch and Sir Haber, you know, at that time that agriculture is a very big industry and they need a lot of fertilizer to accelerate the farming. Okay, so they found that you can actually get ammonia by reacting N2 and H2, kan, N2H2 to NH3. Okay, but if you realize in our nature, kita ada nitrogen gas, kan, our air has 79% nitrogen, 21% oxygen, about 0.03 CO2. Okay, so you will think, we have nitrogen naturally, kan, senang nak produce ammonia, but in nature, in our nature, nitrogen N2 is very stable. Okay, you cannot simply ambil N2 from air, must react with H2 to get NH3. It's not that straightforward. Sebab N2 is very stable in nature, in natural air. However, they found out that if I increase the temperature and pressure of N2 and H2 in a reactor, okay, so imagine I pump in N2, I pump in H2 in a reactor, I increase the temperature, I increase the pressure, you will get ammonia, NH3. So the reaction will occur. It will only occur at a very specific high temperature and high pressure. And that's how ammonia is being produced until now. And to remember the two chemists who have found this, that's why they call it as Haber-Bosch ammonia process. Okay, so then you can see that in a chemical plant, okay, you can see production dia. When I talk to you, I say it's very simple, kan? N2, H2, dapat 2 NH3. Okay? Dalam high temperature, high pressure reactor. But you know it's not that straightforward in a chemical plant. Okay? But you will see that the reactor will always be the heart of the reaction. And in fact, kalau you go and visit a chemical plant, if you talk to a chemical engineer, when we talk about equipment, especially chemical equipment is always a chemical engineer. Okay? They will tell you that normally the plant, kalau dia nak upgrade, dia nak improve, dia nak modify plant, the first equipment yang dia fokus adalah reactor. Kenapa? Sebab reactor is where reaction takes place. The more improved, the more I modify it to improve the performance, the more product that I will get. The more product means more money. Okay, so that's where the specialty or the uniqueness of chemical engineer. Okay, so you probably heard engineers, we have many types, right? We have chemical, mechanical, electrical, aerospace, so on and so forth. Okay, so what are so special about chemical engineers is because in plants that not only produces or any plants that uses chemical engineer has the advantage of understanding the chemistry of the chemistry of the materials that you're going to use. Okay, so mechanical engineer, electrical engineer, dia boleh faham the mechanical part, the electrical part, but this equipment will have to deal with chemical, and only chemical engineers, chemical technologists is the one that has the both knowledge. You learn mechanical part, that's why I'm going to teach you reaction engineering. You're going to actually learn the mechanical part of designing a reactor, and you have the advantage of understanding chemicals. So these are the strength of chemical engineer, and that's why any chemical plant, you have chemicals, either you produce or use chemical, you will see that you will have a chemical engineer. And particularly when you talk about reactor, it's definitely a chemical engineer that is going to design, troubleshoot and maintain a reactor. It's definitely going to be a chemical engineer. Okay, right. So that's why, okay, now I go to understanding what else that you're going to learn. Okay, perhaps you might think designing reactor ni susah sangat ke? Okay, designing reactor is not as straightforward as, okay, tahu temperature, tahu pressure, dah boleh kira design dia, dah boleh buat design dia? No, because besides understanding the operating condition, we also need to understand what we call as chemical kinetics. Okay, so nanti kamu akan belajar. Reaction engineering ni, in a nutshell, is a combination of chemistry and particularly mathematics. Reaction ni banyak, bukan banyak, semua pun pengiraan. It's all basically 90% calculation, 10% reading. You don't need to actually memorize anything. You really need to understand and do a lot of calculation. So that's also my struggle when I teach reactions. But kalau physical class, it'll be much easier for me to actually check on you guys when you are doing the calculation. But it's pandemic, it's online class, I won't be able to actually really gauge your performance when doing the calculation. So that's the challenge as well lah. So again, if you left out at any parts during the lesson for the next 17 weeks, please talk to me. I can really help you. Just that bila dia tak physical, tu cabaran dia lah. Saya tak boleh sangat gauge all of you punya performance. Okay, right. So as I say, chemical kinetics, reactor design, the heart of almost all industrial chemical production, and the selection of a system that operates in the safest and efficient manner. So when we're talking about design a reactor, we also have to consider also the safety aspect as well when we are talking about designing a reactor. Okay, right. So next one, how many chapters are you going to learn? Okay, we're going to have 8 chapters. So out of 8 chapters, 6 chapters are calculation, and the first 6 chapters are the hardest one. And as I told you, nak faham chapter 2, kena faham chapter 1. Nak faham chapter 3, kena faham chapter 2. Nak faham chapter 4, kena faham chapter 3. So on until chapter 6. So let's say if you miss out on chapter 3 or you tak faham chapter 3, the impact is chapter 4, 5, 6. So imagine if you miss out at chapter 2, chapter 3, 4, 5, 6, you will struggle. Sebab dia memang betul-betul berkait. So I really hope that you can attend class, and if you cannot attend class, you please watch the video, and tutorial, you please come. If you ask your seniors, you will know Master, I really guide you during the tutorial. So please come to the tutorial. I will really explain and help you in that. Okay, so 7, 8 is quite easy. Okay, 7, 8 is chapter that is reading, a little bit of reading, not so difficult, right? So what do you learn? What will you output of the course after 17 weeks? Okay, first, analyze problem related to chemical reaction based on the fundamental concept. So what I'm going to do in the class, if you can ask your seniors, when I teach you, I would like to always try to relate to the real problems that you will face if ever you're working in a real chemical plant with reactors. So I have the privilege, because I've been doing my master's, my PhD, and in fact in my PhD also I did a collaboration. I did my PhD in Japan. Okay, and I did some project with the company, especially on the reactor. So with that experience, I will try to relate that what you learn with the real application in the real chemical plant, so that you don't learn only theory, but then when you go to the real world, you don't know how to apply this. So if you ask your seniors, the question that I ask, the problems that I ask in the class, in the test, exam, are usually not problems that you will see in a real chemical plant, and how you relate the theory, the calculation to solve the problems. Okay, so I hope that helps you as well, not only for the class, as well as for the rest, your experience in the real world. Okay, second, you will design chemical reactors. Okay, so we will learn how to design chemical reactor. I will teach you, you will learn from the very basic, start buat eksperimen kat lab tu, okay, from the very basic buat eksperimen kat lab, until you can process the data, until you can design a real chemical reactor. So that's why you need 17 weeks. Daripada eksperimen kita buat kat lab tu, sampai you can get a real chemical reactor. Okay, and last is perform lab lah, which you will do later. Okay, so now let me talk about the assessment. Okay, so for reaction, tak banyak pun dia punya assessment, straightforward. Okay, final exam 40%. Okay, so coursework 60% lah. So the 60% consists of tests. So you have 2 tests. Each test is 10%. you have mini project, one mini project, 20%, and you have the laboratory part. Okay, the laboratory will be another 20%. So I will explain in details what you need to do for each part. So if you ask me, in order for you to get good grades or in order for you to pass, please make sure that you do okay in your mini project in your lab. Test dengan final exam ni is very subjective because you know, right, it's not as straightforward. So please make sure you do well in your mini project, do well in your lab, you already secure a pass. So anything more than that, you have to work hard lah untuk assessment. Okay. Okay, mini project. Right, so I will start first in the project. I think you already tahu kan, dah familiar kan kalau my set mesti ada mini project. Okay, but my mini project, okay, I should say reaction engineering mini project is slightly different because the mini project is really to guide you to build a reactor. Okay, so first of all, you have to group yourself. Okay, kan remember I told you I treat you guys like adult. So you are given the privilege to form your own group for the mini project. But it's only 4 in a group. Okay, so you have 23 of you guys. I know that this semester you have 23, so you will have five groups of 4 and 1 group of 3, which is fine. Okay, buat dulu group. So saya nak 4 orang dalam satu group, and nanti akan ada satu group yang 3 orang. Okay, so then when you already form the group, okay, please assign yourself as student 1 or student 2 or student 3 or student 4. Okay, kenapa? Sebab although this is a grouping work, but I practice both individuality and grouping, meaning although you stay in a group, you are designing one reactor, but each person has its own task to complete. Meaning student 1 ada task dia, student 2 ada task dia, student 3 task dia, student 4 task dia, and these all tasks will be combined to form a mini project. So student 1, you don't have to worry. Student 2, 3, 4 tak buat kerja pun, you just do your part, you are still fine. Student 2 the same, student 3 the same, student 4 the same. So make sure once you assign yourself to the number, you stay the number throughout the whole mini project. Okay, so can you please submit the names to me by today, by tomorrow? I give you until tomorrow. Email it to kytlen@unikl.edu.my. So email me by tomorrow. If I don't get the email, I assume that you want me to group you. Senang je, saya macam tu. Saya tanya student, tolong bagi grouping, saya bagi deadline sampai besok. Anything after tomorrow midnight, I don't receive, I assume it means you want me to group you, which is also fine. Okay, but if you don't want, kamu nak pilih member sendiri, you can do that, but make sure submit it before tomorrow midnight. Okay, so once you dah ada grouping, each grouping you will be assigned a type of chemical. So maybe production of phenol, ammonia, ethylene, ethylene glycol, so on and so forth. Each group chemical yang berlainan. Production rate, I will give you the production rate. For example, 200,000 metric ton per year, 200,000, perhaps 100,000 kilogram per year, so on and so forth. So setiap group ada chemical dia, ada production rate dia, and a type of reactor. So you will learn many types of reactor, but the main ones only 3. So we will learn 3 types of reactor: batch, PFR, plug flow reactor, and CSTR, continuous stir tank reactor. So one group will get one type of reactor. So please make sure you check this before you start doing on your mini project. So once I get the names, I will release everything on VLE. Okay, so now let's talk about what you need to do on mini project. Okay, mini project saya have 2 stages. Okay, why I have 2 stages is because I don't want you guys are burdened until the end of semester, tiba-tiba minggu 17 tu kena hantar banyak benda. So what I do, because mini project ni banyak quite a lot of tasks. So rather than putting all together at 1 week, I split it into 2 stages. So you will have 2 stages of submission. Okay, so stage 1 you will submit by week 7. Stage 2, you will submit about week 14. Tapi kita nego lagi lah kemudian. If I feel that you are burdened, you need more time, we will then discuss later. But for today, as of today, the submission for stage 1 is on week 7. I will announce to you when, and I will announce to you the exact date, the time, and stage 2 on week 14. So as I told you previously, you can ask your seniors. I'm very particular about deadline. If it's on Friday 5:30, it's Friday 5:30. You submit 5:31 pun saya dah tak terima. Okay, but again, as I told you, you can ask your seniors juga. If you really cannot submit on certain reasons, okay, what I need is you have to request to extend the submission to me before the deadline. So before the deadline, 1-2 days before the deadline, if you feel that you really cannot submit because of certain reasons, valid reasons, I may allow the extension. Okay, I may allow. I don't say that I will, I may allow, but you have to request before the deadline. If you assume you don't submit and you assume that I will give you the deadline, I will give you the extension, I will not give you the extension. Okay, so that's, you really need to understand the condition, things that I need. I'm very particular in the class on timing. Okay, so I give you the leeway. You may request, but request before the deadline. Okay, so when you submit the stage 1, okay, let's say you dah submit kat week 7, I already award you the marks for the stage 1. So stage 1 tu 40%. So means lepas dah habis stage 1, you dah submit the report, you don't have to do any more for the stage 1. You just proceed to go to the stage 2. So stage 2 tu you buat pada minggu on the week 14, you submit. Okay, so then you can see every task tu ada specific student dia. So for example, macam proses background, part 1 student 1, part 2 student 2, part 3 student 3, part 4 student 4. Stage 2 pun sama. Setiap part tu ada student dia. Okay, you may share certain marks. Okay, macam format, references, appendices tu you share the marks. But individual part tu is really individual work. Meaning it's still one report, but everybody has its own part in the report. Okay, so if let's say you miss stage 1, katakan kamu tak submit markah stage 1, meaning you already lost the 40% of the entire mini project marks. Okay, so make sure you submit both stages on time. Okay, so then if you may wonder what do we need to do for mini project, for information, mini project dah start lah sebab minggu 7 dah kena hantar kami sekarang. Actually you already need to start to do on your mini project. So you can see clearly mini project saya, nanti kamu pergi VLE, nanti kamu download. I have very clear instruction already what you need to do for each of the group. Okay, so sekarang dalam stage 1, bila kita we have to design reactor. In stage 1, we need to understand first the process. So you will stay in stage 1. Okay, student 1 ni dia punya part is understanding the process to produce your assigned chemical. So for example, let's say you are asked to you are assigned production of phenol. Okay, so apa peranan student 1? Student 1 is to actually discuss what are the possible methods that is being used to produce phenol. And biasanya method ni berbeza because of different types of reaction. So you know that to produce one chemical, it doesn't necessarily mean only one type of reaction. It might have different types of reaction to produce the same chemical. So when you have different reaction, automatically dia akan jadi proses yang berlainan. Sebab apa? Sebab bila kamu ada reaction berlainan, raw material pun most likely dah berbeza. Or the condition, operating condition pun dah berbeza. So it become two different methods. So student 1, that's your role. You find from literature, you find the two possible method to produce your assigned chemical, and then the rest you can read what you need to do. Okay, student 2, your role is to discuss on the raw material and the product. So meaning, let's say student 1 dah decide method 1. Okay, so student 1 have to inform student 2, okay, I choose method 1. So daripada method 1 ni kamu discuss apa raw material dia, apa produk dia. Okay, the details of what else is on the mini project. To part student 2. Student 3, you will discuss on the reaction itself. Kamu fokus on the reaction itself. Kamu kena faham how the reaction takes place, the chemical equation, and the condition of which the reaction takes place. Of course, this is obtained from literature. Bukan kamu sendiri reka, kamu cek pada literature. Kalau tidak balas ni, apa condition dia. And lastly, student 4, in stage 1, you will just discuss briefly about the assigned reactor that you are given. For example, if you are given a CSTR, kamu discuss je pasal CSTR tu, tapi just briefly first. Okay, so that's all you need to do for stage 1. Okay, alright. So if you ask me, this is a very popular question. Student might ask how long, how thick the report should be. For me, as long as you answer all the assigned tasks, okay, for example, kamu tengok kan, setiap student ada task dia kan, as long as you hit everything that is in the task, it's already enough. You don't need to do very big, very thick, very long one, no need. As long as you answer what you are asked, that is already fine for a mini project, okay? And then stage 2. So stage 2 yang part susah sikit lah, but stage 2 will take later. Stage 2, you have to, stage 1, you don't actually need, that's why saya buat permulaan. So stage 1, as the class goes by, you can already do stage 1. You don't really need the class to do stage 1. Stage 2, you really need to attend the class. But stage 2, each student also will have his assigned part. So for example, stage 2, student 1 buat mass balance balik. So you have learned in CPP, right? Unfortunately, masuk reaction kena buat balik mass balance. So student 1, dia akan buat mass balance sebab you have the assigned production rate, right? Kamu ada assigned production rate, kamu ada reactor, you will do the mass balance for the reactor, bukan the whole process. Just the reactor, buat mass balance untuk dapat how much in. Because you already know how much production rate, right? So you need to do back calculation to know how much raw material that you need. Okay, stage 2, you will do what we call as stoichiometric table. This one you memang tak pernah belajar. We will learn in chapter 3 later how to do stoichiometric table. Student 3, student 4, you will focus on kinetics, you will focus on the design and sizing. So finally, at the end of stage 2, kamu akan dapat satu reactor. So you will sketch, you will design, you will tell me the volume of the reactor, how the reactor looks like, so on and so forth. Okay, so stage 2 kamu jangan bimbang sangat. Stage 2 memang susah. You have to go to the classes, then you will understand. But stage 1, you don't really need the class, you can really do on stage 1. So please don't wait until minggu 6 baru nak buat. Basically, you already have to start doing on stage 1. Okay, right. So next, I'm a very green person because my research is in green energy. So you don't need to print anything in my class. So all your submission, even sebelum pre-pandemic pun, kamu tanya seniors kamu, dia tak payah print. Saya tak suka printing benda ni. You just submit soft copy to VLE in PDF format. So I will open a folder submission. Kamu just submit in PDF. Combine semua group. In your group, you combine everybody reports and you submit one report for each group. And let me remind you, I don't tolerate plagiarism. Okay, all the reports I will check through Turnitin. Okay, and then don't forget. Saya dah ajar 16 semester kan, so mini bukan 16 semester, 8 tahun, 16 semester. Semua report senior kamu yang 16 semester tu semua dah ada dalam Turnitin. Meaning, if you take for your seniors, you copy, I check Turnitin, surely kena tangkap. Okay, so you understand what I'm trying to say. Don't copy, don't plagiarism. You can refer. I never say that it's wrong for you to refer. You may refer, but please don't cut and paste. Not only from your seniors, from internet pun, please don't cut and paste. Turnitin can really catch on plagiarism. So, and since this is individual work, if that one person cut and paste, that one person will be punished lah. Okay, the rest will be fine. So please make sure don't cut and paste in the mini project. Okay, so next, test. So I will have 2 tests. So we kan dalam pandemic, so of course the test will be done online lah, online test. So 2 tests. Test 1 will cover chapter 1 to 3. Test 2 will cover chapter 4 to 6. So when the time comes, I will inform you accordingly on what is required for your test. Okay. So next one, the last one, laboratory. I will not teach you on the laboratory, which is quite unfortunate. Actually, I like to teach laboratory. Sebab why I like to teach laboratory is because actually our Unicare mindset has one, if not the best experimental apparatus for reaction engineering. I kid you not. I come from USM. My degree, master's USM, my PhD in Japan. Okay, Hiroshima University. I kid you not. We have one of the best reaction engineering facilities that I have seen, and definitely way better than USM. I kid you not, USM punya reactor I think 5 liter je kot. Kita sampai 30 liter kot reactor kita. Our reactor are way much cooler than dia. So it's very unfortunate that I cannot teach you the experiment, the laboratory, sebab then I can really relate apa yang kamu belajar kat kelas dengan apa yang kita tengok kat lab. Tapi but it's fine. Madam Nurul Ahmad is also equally, if not more experienced than me. Madam Nurul Ahmad ajar reaction lagi lama daripada saya. Madam Nurul Ahmad will be able to do so. Okay, but you need to understand what are the assessment in the lab. Okay, so for reaction engineering, dia bukan straightforward lab report je. Okay, sebab I believe that most importantly, kalau kita nak buat lab, you must be assessed fairly on your psychomotor. Psychomotor is kemahiran kamu. So instead of 20% lab tu semua kat lab report, I just buat daripada 20% lab markah tu hanya 10% sahaja report. The rest 8% will be on your psychomotor assessment. Means kamu datang lab, kamu buat lab tu properly, I will show you the rubrics, we assess you, kamu dah dapat 8 markah. 8 daripada overall grade tau, lab kan 20 markah. 8 markah tu kalau kamu datang lab, buat lab dengan betul, kamu dah dapat 8 markah. Another 2 is pre-lab assessment. I will explain later apa tu pre-lab assessment. So lab report hanya 10, 8 is on psychomotor, 2 on pre-lab. Okay, so then grouping pun you decide yourself, tapi buat masa sekarang terlalu awal lah untuk lab. So nanti kamu tunggulah bila nak dekat dengan lab. I will inform you to inform Madam Nurul Ahmad for you to form the group for lab. Also 4, not more than 4. So again, maybe you have 5 groups of 4, 1 group of 3. Saya tak nak 5 atau 6 sebab I really want you to experience like really working in a real chemical plant dealing with the reactor. Okay. So for lab pun sama juga. Walaupun kamu buat lab in group, tetapi lab report pun assessment dia individually. Okay. Dalam satu lab report tu setiap orang ada part dia yang dia kena buat. Okay. So for lab pula, kamu kena assign juga student 1, student 2, student 3 atau student 4. Tapi this numbering not need to be rotated every week. Kita ada 4 eksperimen kan. So kalau kamu ada 4 student, 4 eksperimen, let's say eksperimen 1, student tu number 1, student tu student 1. Okay, so means eksperimen 2 dia jadi student 2. Eksperimen 3 jadi student 3, eksperimen 4 become student 4. So if let's say your student 2 in experiment 1, in the next experiment kamu tukar nombor. So kamu rotate. Okay, so jangan confuse. Mini project maintain number. Lab nombor tu kamu kena rotate setiap minggu. Okay, sebab ada 4 eksperimen, rotate setiap lab. Okay, so kenapa saya suruh rotate? Okay, tengok lab report dulu. Okay, sebab apa yang saya nak? Saya tak nak kamu di burden sangat. Sebab saya faham sangat kamu ada 20 kredit. You have many other courses. I cannot demand that you just buat reaction. So, I really try to reduce your burden. Kalau kamu tengok lab report, okay, katakan kamu ada 4 student So, student 1 kerja dia buat summary je. Buat summary, buat result. Kalau kamu student 2, kamu buat discussion. Student 3, kamu buat conclusion recommendation. Student 4 akan buat tutorial question. So, sebab tu kamu kena rotate. Minggu ni, katakan kamu student 1 kan, kamu buat summary dengan result. So next week, eksperimen seterusnya, kamu tukarlah, kamu pula buat discussion. Kawan kamu pula buat yang part lain. Sebab tu kamu kena rotate. So each of you will experience doing each part of the lab report. Tapi kalau kamu perasan, tak banyak kan nak tulis, the most also 1-2 page for lab report. So I think it's quite fair that it's not too burden, but you still have the one that you do. Okay, so that's the most important part. Sama macam mini project, satu group tapi setiap orang ada kerja dia. And then second, please download the latest lab manual. Saya dah ubah drastically in the lab manual, dah tak sama dengan senior kamu langsung. Make sure you download the latest one from the VLE. Okay, the previous one dah tak applicable. Saya dah tukar secara dramatically the lab report kamu. Okay, right. So next one. Okay, remember I told you we got pre-lab, right? So we got pre-lab assessment. Okay. Bukanlah nak menyusahkan kamu. Okay. Kenapa saya buat pre-lab assessment ni? Sebab I would like to try to simulate the real experience if you're in a chemical plant. Okay. What do I mean by this? Okay. Pre-lab ni adalah apa yang kamu kena buat sebelum kamu masuk lab ni. Sebelum kamu, katakan hari ni kamu nak masuk lab kan, kamu kena isi dulu pre-lab ni, submit kepada Madam Nurul Ahmah, baru kamu boleh start buat lab. Kenapa? Sebab in a real chemical world also, before you start going to a chemical plant, you have to do homework first. Kamu tak boleh sebarangan datang kerja masuk chemical plant. Tak boleh. You have to do certain amount of homework. So this is the same concept. So what is the homework? For student 1, let's say minggu tu kamu student 1, untuk pre-lab, apa kamu buat? Kamu kena buat calculation dulu, chemical calculation. So that when you come to the lab, kamu dah tahu apa chemical nak prepare, how much is needed for the preparation. So tu peranan student 1 masa lab day. Student 1 peranan dia kena prepare chemicals on that experimental day. Okay, sebab tu kena rotate. Minggu ni dia kena prepare chemical, means dia kena calculate, dia kena prepare chemical. Student 2 pula, you have to summarize the experimental procedure. Sebab on the experimental day, student 2 tu yang kena run the experiment, dia yang kena arah dia punya group member according to the procedure. So he or she must be familiar with the procedure first. That's why student 2 pre-lab dia kena buat summarize experimental procedure. Student 3, kamu kena practice, pre-lab dia kena buat sample of calculation. Sebab during the real experiment day, you are the one who recording all the experimental data. Sebab tu pre-lab tu is to practice you to know what you have to fill up so that during the experiment day, kamu dah tahu apa yang kamu kena buat. So that's your role in the experiment day, student 3. And lastly, student 4. Okay, student 4, pre-lab dia hantar selepas lab. Sebab student 4, kerja dia, during the experiment, you will observe and you will troubleshoot problem. So let's say masa eksperimen tu ada problem ke, reaktor bocor ke, temperature tak naik ke, apa-apa masalah pun, student 4, you are supposed to observe and troubleshoot. So then you will report in your pre-lab assessment and you submit after the lab session. So this is really to simulate a real chemical plant. If you're dealing with a reactor, you have all these roles of individuals working together to ensure the optimization of the equipment. So I really simulate a real chemical plant. That's why you have all these rules. So it seems a bit tedious, tapi again I told you this class is not only about passing. I really like to try to let you experience the real working world. Okay, so don't worry kalau kamu rasa ni macam kompleks sangat, tak apa, nanti sebelum lab saya explain lagi. Okay, lastly psychomotor assessment ni yang 8 markah yang saya diberi. As long as you come to lab, okay, make sure you print this form, satu group satu form, you pass to Madam Nurul Ahmah, she will assess you during the lab. So kalau kamu tengok senang je, kamu pakai PPE, kamu buat eksperimen betul, kamu clean your apparatus after the experiment, kamu dah dapat 8 markah out of 20 marks for your laboratory. Macam tu je. So please make sure you do this as well. Okay, right. Okay, so next one, last one. To explain kan saya kata reaktor kita canggih kan. So let me explain why I say it's cool. Okay, now experiment, we have 4 experiment. Okay, so experiment ni is on all the 3 main reactors that we are going to learn. Okay, so first of all, experiment 1. Okay, experiment 1 ada 1A, 1B. Okay, make sure when you are given the experiment, make sure you check eksperimen 1A ke 1B. Sebab 1A, 1B adalah 2 eksperimen yang berbeza. Kamu hanya buat salah satu eksperimen. Okay, so this is what we call as a batch reactor. Kalau kita tengok gambar ni, batch reactor adalah yang vessel ni. You see there's a vessel here. This reactor is actually about 10 liter reactor. Right? So you can see karakteristik, saya explain sikit lah pasal reactor Kamu akan belajar juga kemudian. Okay, batch reactor is a closed system. Okay, kenapa kita tahu batch reactor ni closed system? Kalau kamu perasan, dia hanya akan masuk the raw material. Okay, so means at minute 0, I put in my raw material. Then when the reaction takes place, nothing goes in, nothing goes out. It's a closed system. So let's say reaction dia 10 minit. 10 minit tu saya tak buat apa-apa. I let the reaction takes place. After the reaction has occurred or the reaction time has ended, only I will take out my product and my unreacted raw material. So kamu kena faham dalam reaction, very rarely all raw material will be converted into product. Mesti akan ada yang unconverted raw material. So lepas reaction, kamu akan dapat a mixture of product and unconverted reactant. And in our lab, we will conduct saponification. Reaction yang menghasilkan sabun is called saponification. So in this, we will use acetic acetate and sodium hydroxide. So acetic acetate, sodium hydroxide, you will produce sodium acetate. So sodium acetate itulah sebenarnya sabun. Okay, so we will use that reaction. So imagine we will put in acetic acetate, sodium hydroxide, reaction takes place, then we will get the soap. Okay, so this is a batch reactor. Then kalau kamu tengok macam kompleks kan? Okay, kenapa kompleks? On your left hand side, this is actually a water bath. Why need a water bath? Saponification is also a reaction that needs a high temperature. So means I need to heat up my reactor, right? Okay, so kalau kamu perasan reaktor ni, dia ada dua lapisan tau. The real reactor is the vessel inside, but you will see there's an external vessel. We call it as jacket. Dia bukan jacket baju. Jacket is the vessel that encapsulates your reactor. So dalam vessel yang luar ni, jacket ni, it can be either heating jacket or cooling jacket. Kenapa ada dua? Sebab katakan reaktor kamu memerlukan suhu tinggi, we have to flow in heating fluid. So it become a heating jacket. So this heating fluid, the fluid that will heat your reactor, it can be either water. Kalau reaction kamu bawah 100 Celsius, I use water to heat up. If it's above 100, sometimes we will use oil or we will use steam untuk panaskan. So kalau kita nak panaskan, the external vessel tu jadi heating jacket. However, there are cases of reaction where you need to cool it down. Kalau reaction tu memerlukan cooling down, it become cooling jacket. And the fluid will become cooling fluid. And usually we will use cold water lah, so on and so forth. Okay, so kalau kamu tengok, mesti ada dua lapisan. Yang dalam tu reaktor, yang luar tu adalah heating jacket or cooling jacket. And batch reactor akan ada stirrer. Okay, kamu tahu kan reaction, if we want to make sure the reaction occurs consistently, occurs uniformly, we need a stirrer. So stirrer tu apa kepentingan dia? First, to distribute the concentration. Second, if you have heat, to distribute the heat. Sebab tindak balas ni, kenapa dia kompleks? Sebab reaktor, kalau reaktor yang besar, kalau kita nak reaction yang optimal, setiap part in the reactor tu, reaction kena berlaku pada kadar yang sama Means heat, concentration has to be consistent throughout the reactor. That's why we have a stirrer. Okay, so next. Saya pergi pada CSTR. Okay, I go to the next one. Experiment 2. Experiment 2 is CSTR or we call it continuous stir tank reactor. So kalau kamu tengok sini, first, reactor dia kat mana? Reactor dia yang belah kanan ni. Okay, so this reactor is about 15 liter if I'm not mistaken. I think so. 15 liter reactor. Tapi kamu tengok macam sama dengan batch kan? It's actually about the same. The only different, okay, persamaan dia, dua-dua ada stirrer. CSTR pun ada stirrer. Sebab tu dipanggil stir. Sebab ada stirrer. Tapi kamu tengok sini ada ayat continuous. Meaning, CSTR ni, kalau kamu perasan on the left hand side, ada these two tank, right? This two is the feed tank. So means kita ada dua feed kan? Sodium hydroxide, acetic acetate. So one tank we will put sodium hydroxide, the other tank we will put acetic acetate. So kenapa CSTR ni ada feed tank? Kenapa batch reactor tak ada? Sebab CSTR ni continuous, meaning throughout the process, we will continuously pump in sodium hydroxide, continuously pump in acetic acetate to the CSTR, and at the same time, it will continuously flow out. Kamu tahu kat bawah ni ada piping kepada product tank. Yang bawah, yang saya tengah point ni, this is your product tank. Means continuously pump in feed, continuously pump out the product. That's why it become a continuous open system. Tu je beza je daripada batch. Kalau batch, masa tindak balas berlaku, nothing goes in, nothing goes out. CSTR during the reaction goes in, flow in, flow out, flow in, flow out. Okay, so that's why it's called continuous stir tank reactor. And experiment 2 pun ada A and B. Why? A is to discuss on the effect of residence time. We will learn later. And second is the effect of temperature. So you will do either experiment A atau experiment B. Okay, saya ada berapa minit lagi ni? Okay, seminit lagi. Okay, right. Next, third reactor that you will learn is a plug flow reactor. Okay, so plug flow reactor is the one that is different from the others. Kenapa lain? Okay, kamu tengok sini dia punya apparatus kan? Okay. First, let's see bawah ni pun ada 2 feed tank. So kalau ada feed tank bersama-sama, most likely dia akan open system. So PFR is also an open system. Tapi apa beza dia? Okay, so feed tank, dia akan masuk, dia akan pump in through the bottom of this tank. So kalau kamu nampak vessel ni, if you see inside there's a coiling pipe. Okay, reactor tu sebenarnya yang coiling pipe tu. Okay, so means you imagine the reactor flow in, dia akan melalui coil punya piping tu. Okay, mungkin kamu perasan kenapa piping dia coiling, sebab kalau kau imagine, kalau kita nak letak straight, it will take a lot of area, surface area. So saya nak jimatkan ruang, saya compact dia menjadi coil. But you will ask, kenapa ada vessel yang kat luar tu? Vessel kat luar tu adalah heating jacket or cooling jacket as well. So kalau kamu nampak fluid yang kat luar tu, sebenarnya dalam kes ni kita guna air. Kita guna air untuk heat up your plug flow reactor. Yang plug flow reactor tu sebenarnya pipe ni je. Okay, so again continuous. Go pump in from bottom and it will goes up from the top. So in, out also a continuous process. So that's the third reactor that we're going to learn. So imagine dalam your whole semester, you learn batch, CSTR, PFR. And last one, last apparatus, experiment 3 as well. Ada experiment A, ada experiment B. You will do only one of it depending on Madam Nurul Ammar, which one lah, A atau B. Last one, I know dah tak cukup masa sikit ya. RTR. Okay, RTR ni is the coolest one that I think, sebab saya suka reactor, so saya rasa macam cool gila lah. Okay, why this is cool? Because in this apparatus, you have a combination of 3 types of reactor. Kalau kamu perasan yang dua yang panjang ni kan macam PFR. So it is indeed a PFR. Tapi instead of one PFR, we have 2 PFR connecting to one another in series. So nanti kamu akan belajar dalam reaction, tak semestinya kita guna satu reactor. Sometimes you will use 2 reactor connecting in series or connecting in parallel, which I will teach you later. And we have CSTR, single CSTR kecil ni, and we have CSTR in series. 3 CSTR in series, meaning dia akan masuk daripada feed tank, masuk kepada CSTR pertama, flow to the second reactor, flow to the third reactor, baru reaction tu habis. So so that you will learn how sometimes instead of using satu reactor besar, kita boleh guna smaller reactor connected in series and you still get the same performance that you achieve by using only one reactor. Okay, but I will explain later dalam kelas juga. Sebab tu saya suka kalau saya ajar lab, sebab I can really relate what you learn and what you do in the lab. But it's fine, I will try my best as well. Okay, so since I got no time, last one on the reference book. Okay, so if you ask me, this is the main reference book, not only in UniKL MySet, in all over the world. Anyone who's taking reaction engineering, you will need to use Fogler. Okay, so Fogler is the main reference book that I will use as well in the reference. But if you cannot get the book, it's fine. My lecture notes, my lecture material should be more than enough for the class. Okay, so that's all for today. I'm so sorry I take away 3 minutes of your time. Saya tak sempat Q&A, but it's fine. I will see you again next Monday for the next lecture. Tak ada tutorial lagi, tutorial tak start lagi. We will continue with lecture next Monday according to timetable. Okay, so any questions minggu depan Sorry Alright, thank you everybody. Goodbye, see you next week.
Thank you, Doctor.
Thank you. Thank you.